All right, fifth graders, welcome back to video 2, continuing our lesson on 4.9 or 4-9, comparing shift patterns and how we kind of can move these numbers to the left or to the right simply by how many zeros are after a whole number or how many decimal point place values there are by the number we're multiplying by. But like I said, I think to simplify this and make this as easy as possible, solve them like we know how to solve them. And then if you see some zeros on the end of it, in the case of like multiplying, for example, number 13, 1.7 times 100, that's 17 times 100, which becomes 1,700, the 2 zeros on the back of 17, and then you add the decimal point in at the end. So I said I would go through problems 16, 17, and probably 10 and 11 just to kind of show you again how we're solving these problems just very quickly. So for number 16, again, the actual problem itself is 9 times 4, which is 36. All right. And now I'm going back to the problem to determine how many decimal point place values are there. One behind the top number, the 9 is behind the decimal point, and in the bottom one, the 4 and the 0 are both behind the decimal point. Okay, so that means a total of 3. So this is much like the problem 9, where we have 1 and 2 in our answer right now, but we need a third. So moving from right to left, I'm going to add that 0 in front of the 3. So 1, 2, and then the third one becomes the 0 in front, and then the decimal point. All right, so it's kind of weird because we don't actually have enough place values to put the decimal point in the right spot until we add that 0 in front, not behind, but in front of the 36. All right, and then the last one, number 17 here, is 60 times 6. And again, I'm looking at it as 6 times 6 is 36. There is 1 0 in 60, so I'm throwing that 0 behind it, so it's actually 360. And then I look back to the problem and identify that there's only one number behind the decimal point, which means this 0 is behind the decimal point, and my answer will become 36. All right? And those are the ones where we have some different numbers other than the 1, just moving those same numbers. So for 10 and 11, obviously the 48 is not going to change. The 0.48 is going to stay 48. Okay? Like this, but it is 48 times 10, so there is 1 0 in that 10, so it becomes 480 because 48 times 10 is 480. Then I go back up to my problem and determine that 2 numbers behind the decimal point in that top number, none in the bottom. So I go to my problem and say that the 0 is behind the decimal point, the 8 is behind the decimal point, and my answer will become 4.8 or 4.80. Number doesn't change. That 0 at the end of that decimal number doesn't impact it in any way. So if I enter that into Schoology as a 4.8, I'd be fine with that. And then the last one I want to go through on this page, guys, is 5.6 times 0.01. Again, the problem itself is 56 times 1, which is 56. And then I'm looking at 1, 2, and 3 numbers behind the decimal point. So 1, 2, and 3. Have to add that 0 again behind that decimal point to get my answer of 0.056 or just 0.056. All right, so think about what I just said for that previous video, and that's going to apply to our next page as well. Because this tends to get a little confusing for students, but I want you to think we are going to introduce you to something called an exponent now. And this is probably one of our first times talking about an exponent this year. So I really want to stress what an exponent is or what it does. Okay? We are not multiplying the number by the exponent. So we're not taking 10 times 1 or 10 times 2 or 10 times 3. Okay, we are taking the base number, we call that the base number, the 10 in this case, and we're multiplying it as many times as the exponent tells us to multiply it. So in the case of number 18, I'm going to skip that top part because I do think that that gets to be almost more confusing than help explain. There's just a lot of statement there. But if I'm looking at 18 here, okay, I'm seeing the problem itself is 0.8 times 10 or 0.8 times 10 to the what we call the first power. Okay, when we see 10 to the first power, that means we are going to have 1 10. Well, that means we just go back to the original problem of 0.8 times 10. So 8 times 10 is 80. And then there's one number behind the decimal point in the problem, so there has to be 1 in the answer. So the answer becomes 8. All right, and again, I'm going to stand by the same thing I said in video 1. Solve what you can solve first. Set up the problem, solve what we know. So the next one, that becomes a little trickier because now we have to know what 10 to the second power means. All right, so 10 to the second power, I'm going to come to my space over here, the open space. 10 to the second power actually means, it means the same thing as taking 10 times 10. There are 2 10s involved in the problem. It's not 10 times 2, so our answer doesn't become 20. The 2, the exponent, tells us how many times we are going to multiply 10 by itself. Okay? So in this case, or how many 10s we're going to have in the problem. So here's our 1 10 and here's our second 10. This number and this number will match up. Okay? So 10 times 10 is 100. So that's where I would come down here. And we are telling you right now that 10 to the second power means the same thing as 100. So now just solve it like we did in the last part of the video, or the first video. Okay? 100 times 8 is 800. But our problem has one number behind the decimal point in the problem, which means I need one number behind the decimal point in my answer. So we will go from 800 to 80 based on the fact that there is a decimal number involved. All right, so the same thing here. 10 to the third power doesn't mean 10 times 3 or 30. It doesn't get to that. What this 3 here is telling us is that we will have 10 times 10 times 10. 1, 2, and 3 10s involved. We need to have that number match up with this number right here. Okay, this one here and this one here need to match up. So now, that might seem like a difficult problem, but we're multiplying by 10s, right? So it's relatively straightforward. 10 times 10 is 100. 100 times 10 is 1,000, and that's where we're getting this 10 to the third power means the same thing as 1,000. All right, so our actual problem here is 8 times 1,000, which is 8,000. Again, one number behind the decimal point in the problem, which leads me to one number behind the decimal point in my answer. All right, so as you look down the page here, we kind of remove that element of what does the exponent stand for, or what does 10 to this power stand for after problem 19 here. Okay, so I'm going to skip down just based on time here. I want to make sure we understand what those concepts are. So I'm first going to erase my work on the side here so I can again kind of show you in a little bit more space what that looks like. All right, and let's jump down to question 20 here. So we are 4.8 times 10 to the first power. Well, again, what 10 to the first power means, again, the exponent is not telling us we're multiplying. In this case, it works out that way, but that's not what that means. It means we have 1 10. Okay, these numbers, like we said, need to match up. All right, so this becomes 4.8 times 10. Okay, so 48 times 10 is 480. There is one number behind the decimal point in my problem, which means I need one number behind the decimal point in my answer. So that becomes 48. All right. Now I jump down, and we should have started to see the pattern here, obviously, right? So now it's 10 to the second power, 10 to the second power, which doesn't mean 10 times 2 or 20. It means we will have 2 10s, and we're going to multiply them together. Multiply, not add. Okay? So there are 1 and 2 10s. Again, remembering that these two numbers should match up. We should have the same number of 10s as we do exponent in the exponent. So 10 times 10 is 100, so this one gets replaced with 100. Sorry, kind of small there. That's really gross, but it is what it is. 48 times 100 is 4,800. There's one number behind the decimal point in my problem, which means I need one number behind the decimal point in my answer. So that goes from 4.8 to 480. Now, the book is assuming that you can just start to do this mentally and you can start to shift the numbers one way to the left or to the right. But again, I still think it's in our best interest to simply solve the problems as we know them. If we think about order of operations, guys, PEMDAS says to do the exponents first. Okay, parentheses, exponents is that next thing. So before we do any other multiplying or dividing, we should be solving these exponents. So in this last one, for that example, this is 10 to the third power. What that stands for again is 3 tens being multiplied together. 1 10, 2 tens, and 3 tens. I should have the same number of tens as I have exponents. Not adding them together, but multiplying. So in this case, this is 10 to the third power standing for 1,000, and it always will. 10 to the third power will always be 1,000. 10 to the second power will always be 100. So once we get that kind of memorized as well, that will make this process a little easier as well. So now 4.8 times 1,000 gets us to 48 with 3 zeros. And then there is one number behind the decimal point in our problem. Need one decimal point behind my answer. It becomes 4,800 for our answer. Now I'm going to change up the pace here a little bit. I'm going to do a problem that has 2 decimal point place values in the problem, but it should be the same aspect. And I'm going to go ahead, without writing it on the side over here, I'm just going to replace my exponent number with the number that I know it represents. 10 to the first power we know is 10. We know that 10 to the second power is 100. And we know that 10 to the third power is 1,000. So I'm just going to go ahead and replace that. That is the same. And if you look at every example on the page that we've done already, or every example that the book gives us, they show us that 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000. Whether we understand the why at this point, at least understand that point of it. All right? So then, let's look at it. 623 times 10. That becomes 623 with 1 0 behind it, or 6,230. There are 2 decimal point place values in the problem now, so I need 2 numbers behind the decimal point in my answer. Those are going to be the 0 and the 3, so my decimal point goes between those two, and it becomes 62.3, or 62.30. Again, doesn't really matter if the 0's on the end of it. All right, and then the last one, or not last one, next 2 here. So this next one becomes 623. Because 100 has 2 zeros, I'm going to throw 2 zeros behind it. So 623 times 100 gets us to 62,300. There are 2 decimal point place values in our problem, which means I need to throw these 2 zeros behind the decimal point there, and my answer becomes 623. Notice that our numbers are shifting 1 spot to the left each time. They're getting 1 place value larger each time. This one was 62, the next one was 623. And the last one, 623 times 1,000 gets to be 623 times 1,000, 3 zeros and 1,000. And there are still only 2 decimal point place values in the problem. So I go back here, and these back 2 zeros go behind the decimal point, so my answer becomes 6,230. Notice our numbers just progressively get 1 place value larger all the way through. Now again, guys, I know I could dive into this larger and I could go into more problems. I would suggest practicing this skill and understanding that pattern a little bit more, just so you can kind of wrap your mind around that concept. I will say this. Use what you know already before this lesson. Understand if once you get the problem established and set up, solve it like you know how to solve it. This is designed to kind of get you to understand the why. It's designed to maybe make this a little bit more mental math, but in all honesty, guys, if it helps you to just solve the problem and then add the decimal in at the end, please do it that way. That would be my recommendation moving forward. All right? So good luck on that, guys. There should be an exit ticket for lesson 4.9 or an assignment for 4.9. Please make sure you do that. And if you are having problems with that, please contact your teacher. They are more than willing to help you. So please do that, and good luck on that assignment.